So welcome everybody. This is the last breakout session for today. So thank you for showing up. I'm looking forward to close this, and hopefully this will be a useful session to you. So my name is Jonathan. I'm responsible for the development center that we have here in Berlin, where we have over 2,500 technical folks for Amazon working on many AWS services, on lots of other products for Amazon, ranging from Alexa to the retail website and lots of other technologies we use in our fulfillment centers. I've been with Amazon now for a little bit over 11 years and launched in my tenure with Amazon, I think 7 AWS services. So I'm very familiar with how we develop software, how we release software, how we operate and run software. And today I want to talk to you about that and explain to you a little bit what are some of the lessons that we learned, how do we run our software teams essentially. A lot of the questions that I get from customers are around that, right? Like if you think about Amazon, Amazon is even though it's a pretty large company, it's still able to innovate so quickly, right? We're releasing so many products, so many features every year, and the question I get all the time from customers: how is that possible? Why are you not slowing down? And this is what I want to talk to you about today, is kind of explain a little bit how we work internally, and hopefully there's some lessons in there that you can take home and maybe adapt at your company. Obviously, not all of that will work for you, right? Like those are our lessons specific to our circumstances, to our culture, and those are not generally true, right? Like those are always to take with a grain of salt. One important thing to understand about Amazon, before we talk a lot about those details here, is that even though Amazon from the outside looks like one entity, actually internally it's hundreds of small businesses essentially, right? Like hundreds of small teams that operate autonomously, and that's kind of the core of a lot of the ideas that I'm talking here about, where in particular if you look at AWS, you can think of every AWS service is its own mini startup, if you like, where they have their own roadmap, agenda, goals, and the freedom to operate on it, and I will talk about it a lot. So don't think of Amazon as like one big top-down company. Think of it as a hub of startups, as a hive mind essentially, and that's how we're able to execute so quickly. If you look at the software development lifecycle at Amazon, it's not that different than anywhere else, right? We have our developers, they build, test, release software to customers, and then we monitor, adapt our plan if necessary, and kind of iterate, right? Sounds simple. That's what we're doing. That's probably what you're doing. But obviously in practice, things are a little bit more complicated, right? So today, I want to cover kind of 10 big lessons that we learned over the years that we kind of paid for blood, sweat, and tears, right, in order to see how can we operate our business. Again, some of those are very specific to our kind of business, but I think some of those might be very interesting to you too. So let's start with the first one about microservices and services-oriented architecture. Before we do that, we need to go back 25 years, right, and look at how Amazon used to be. And if you would look at Amazon.com, the Amazon.com retail website that time ago, you would be looking at a 5 gigabyte big C binary, right? Like so, where the whole Amazon.com retail website was that one binary, where we had like everybody work on that single code base, and obviously that didn't work well for too long, right? But that's how we started. That's probably how all of you started. When you have a new project, you start building on it. You have a small team, right? It grows. It becomes a big monolith, and it works fine for a certain time. But then at some point, it becomes too big, right? Like you have too many developers working on a single app that you release regularly. So back in the day, we used to have like a weekly release cycle, right? Like the weekly release train. Once a week, there was supposed to be a deployment. But as I imagine a lot of you are familiar with, every now and more over time, like that quite doesn't work like this, right? Like Team A introduces a bug that blocks Team B, and that's why Team B, C, D, and E cannot release. You want to release, but Team D needs to do a rollback, and now everything is screwed up, and it takes months until you have a release, right? So obviously this escalated the bigger we got and the more we had to scale. So at that point, we made the decision, and thankfully we had Jeff Bezos personally kind of be very much behind it and drive it top down to move to what today you would call a service-oriented architecture, right? At the time, this term didn't exist, but that's essentially what we did, right? Like we broke up our product, the monolith, and lots of small individual services that had to do one thing and do that well, kind of a little bit the Unix philosophy, right? Have small, dedicated, modular, encapsulated services or products or components, however you want to call it, right? That serve a single purpose. And then you have APIs, like a defined interface that you speak to the rest of the world. And then internally, that means you can do whatever you want in terms of technical re-architecture, in terms of refactoring, in terms of migration, in terms of programming language, in terms of framework. Who cares? As long as you speak your API, your clients, your customers, be they external or internal, are fine. They don't have to care, and you're decoupled from them, right? Most of the time, we don't go as far as really microservices, right? But like more, I don't know, mid services or medium-sized services, right? Like that would be probably the most common form. But today, that's how you can think of Amazon, both the retail side of things and AWS in particular, right? Like if you go today to Amazon.com or DE, and you look at an item, you're actually talking to thousands of services in the background, right? Like there is the main page that renders, that then goes to a service to get the price. It goes to a service to get the picture. It goes to a service to get the recommendations. It goes to a service to load the reviews. These services, again, depend on dozens and dozens of services. So you have kind of a call tree, which might be thousands or even tens of thousands of internal APIs and services and teams that you're actually touching without knowing it. And that was kind of one big lesson that allowed us to decouple. Right, so that allows us to be more independent, and instead of having one big app, we got to lots of small apps, right? Like the other big change is how do you organize your teams to do it? And that has a lot to do with what I said earlier about these autonomous teams. So with the idea of having small decoupled products, we also have small autonomous teams that own these products. We call these teams two pizza teams because the idea is you can feed them with two pizzas. Obviously, we're talking big American pizzas, right? Like not the smaller German ones, right? So the idea is like probably most companies would call this nowadays like a Scrum team. So you have anywhere from 5, 6, 7, 8, maybe 10 on the high end team members in that team, right? So most of them would be generalist developers, and they own and operate, right, like a particular, maybe the whole product, if it's a smaller product, maybe if it's a larger product, a certain component of it, a certain feature, right? Like maybe you have a console, a front end, and a back end, and you have three teams. One owns the console, one owns the front end, one owns the back end of it. But the general idea is these teams are the owners of that product, of that component, right? Like they define what is actually the goal, what is our roadmap, right? Like both on the business side and on the technical side. Should we use Java? Should we use Ruby? Should we use Go? Should we use .NET, right? Like whatever you think makes the most sense to implement this, right? So they have a lot of autonomy, which then gives them agility to execute and operate. The important thing is, right, like we hold them accountable at the end to actually the results that they deliver, right? So I'm sure you're familiar with the quote from Spider-Man, right? Like with great power comes great responsibility, and this is the same idea, where those teams are empowered to make their own decisions about how they implement a particular problem, what are the most important features to do next, what the architecture should be, right? Obviously, there are best practices. Obviously, like not every team reinvents the wheel, but you have the freedom and autonomy to do so if you believe this is the right thing to solve your problem. And those teams also own operations for these products, right? Like you own the problem end to end, and that means design, implementation, release, right? Operations, monitoring, support, right? So if you have a problem with an AWS service, we have our global support team that is available to you. But if those folks can't answer your problem, if those folks think there is an underlying problem, they will page the service team, right? Like they will page the engineer implementing the service, and they will join that resolution to help you. So this is like a very, very important idea to how Amazon as a whole operates, and in particular for how at AWS we run our services. You have these dozens and hundreds and thousands of teams that own a particular component end to end, and they're responsible for delivering it, right? Like they are responsible to figuring out what is the right way to solve this problem, how do we solve it, where do we solve it, how do we deliver it, and so forth. And then we hold them accountable to these choices that they made. And if you apply that, that gets you from like lots of developers working on a big monolith to small teams operating on distinct services that are decoupled as much as possible, right? And they can work on independently, develop them independently. The remaining question is, of course, how do you release that, right? Like how do you get that into customers' hand, and how do you automate that part? And that gets us to self-service tools. So the idea here is that we want to enable our teams to release the products and operate them with, again, as much autonomy as possible, right? So we provide a very small number of internal tools, like a release tool or maybe a testing tool, where we saw lots of teams need that. It makes sense to offer it, but we try to make these tools as technology agnostic as possible, right? We don't want to constrain you. We say you can only use Java, or you can only use C++ or whatever it is, right? So these tools are available. They encourage best practices, right? Like they implement a lot of the learnings that we learned over the years in terms of how do you best release, how do you best test, how do you best ensure that you have encryption everywhere and so forth, right? But the idea is, again, they solve one particular problem. There is a tool for testing, there is a tool for release, there is a tool for monitoring, there is a tool for log management, right? And then they're offered to you in a toolbox, essentially, and you pick and choose what you need in order to manage your problem and to release your software and to manage and operate it. And that is, again, fundamentally part of that idea of we empower you, we give you a selection of best practices and tools and standards, but at the end of the day, you make your choices, right? Most teams will pick kind of the standards from that toolbox. There is like, here is the standard web framework. That works for lots of people. Probably start there. But if you when you run into limitations, when you see, oh, we need to deviate from that, that's where you still have the autonomy to do so, right? Like, and you're not constrained. You don't need dozens of approvals to say, I don't think it makes sense to use Java for my low-level, low latency database I need to implement, right? Like, maybe use a different language for that, for example. So that's your choice. Lots of teams will use the standard, but you can deviate at any point in time. It's your decision to make. You might, if you deviate from that, you might get more questions asked, and you will hopefully ask for more feedback and input from other experienced folks. But at the end of the day, your product, your choice, your responsibility, your accountability, right? And this is also how internally over time, and we're large enough, right, like that we have kind of those internal communities similar to an open source community where over time, like the sentiment shifts where this is the most popular framework to do this, right? And then over time, maybe it shifts where that becomes more popular. Not because somebody said everybody has to use this, but just because people recognize that's a more productive way to solve this problem. So that's what gets adopted, right? So let's say there is like a standard authentication library for Java. Your team doesn't want to use Java, right? So maybe you want to use Ruby, so you have to implement this library now in Ruby. And that will slow you down for a while. You will get more questions asked doing the security review and pen test, obviously. But once you did this, now there's a library to do authentication in Ruby, and maybe other teams can use it, right? And that becomes more popular over time. So that's the idea here. One example of these single-purpose tools that we have internally is called Apollo. That's our release tool and our deployment tool, where we recognize that everybody needs, or many teams need to do no downtime deployments. We want to do health tracking of hosts behind your load balancer, right? Like we need version artifacts, we need to do rollbacks and so forth. And that's like our internal tool that is used by thousands of teams, does millions of deployments that we offer teams to use, right? And by now, many teams use that. And that's the prototype to code deploy, which you might know, which is our external service, kind of the external version of that, where for a lot of our external developer tools, they're kind of modeled on top of some of the internal tools that we developed over the years, where at the time when we built Apollo, there wasn't a similar solution available externally. And we saw this is an important problem we have to solve. How do we do consistent, highly available, secure, reliable deployments, right? Where you can do rollbacks and you can maintain availability during deployments and so forth. So yeah, that's one example for one of these tools. So if you have a way to release, the question is, how do you do continuous delivery? And I said earlier that teams have the freedom to use their tool, right? Pipelines is probably the one tool where you will get, the expectation is you kind of have to use it unless you have a very particular reason not to, because we made the experience that having a way to do continuous delivery with integrated testing and release process is super critical in order to have a highly available software, right, and services. So pipelines is our internal version of what you might know as code pipelines, right, which is an automated release tool that allows you to do workflow automation. So it allows you to define your releases and the stages, like what are the validation steps, what are the release steps and automation steps, and so forth. And practically all teams at Amazon use pipelines or the external version of it, which we found is in a very important way in order to ensure consistent, reliable, highly available deployments and therefore highly reliable services, right? So if you use that, you get to a world where now we have, instead of the big monolith with one big app developed by many developers, you have lots of teams working on lots of services, having their own independent, autonomous, decoupled release pipeline, right? And you get to a world where now everybody can release on their own time, everybody's decoupled from another team, you have clear APIs, clear interfaces between the teams, and everybody can develop at their own speed, at their own agility, right? Their own velocity, and you have defined interfaces, defined API contracts between teams. And that's essentially how Amazon and AWS is built, right? Like a typical AWS service internally will be from a handful to a few dozen of these services, right? Like that operate by different teams that have their own pipelines. Maybe they operate one or two or multiple services, typically not too many. And they have their own release schedule, their own prioritization, their own technology that they use, right? Like Team A, even on the same product, Team A might be using Java, Team B is using Go, the next team is using Rust, for example. Then if you enable the teams to do that, you get to like a ridiculously high number of deployments. You might have seen some of those metrics that we published in the past where it says Amazon does millions of deployments, right, through the company, right? And how you get to these numbers is if you just say, okay, you have thousands of teams that have multiple services, right? And then each service does multiple releases a day potentially, and then you have different environments, like there is a pre-prod and a prod stage and a development stage maybe, right? And if you do the math, you get easily to millions and millions of deployments that are happening all the time at Amazon, right? Obviously, it's not a single team that deploys millions of times, but a single team might, through every pipeline, might have a few releases a day or maybe a few dozen, depends on how granular your releases are, right? There are teams that do have release gates because it makes sense for them, like if you don't want to have like a new Kindle app in your app store like 5 times a day probably, right? So there is some maybe manual release, but that will be very rare. For the typical AWS service, they're being released and deployed constantly, right? Which is the whole point of continuous delivery. So with that, right, like we're getting kind of to the basics and the foundation and how do we in general develop software. Now let me walk you through some of maybe of the more peculiar lessons that we learned, that some of them are very much applicable to our business, but I think there are some lessons in there for you too. So one important of them is called pessimistic deployments. So the idea behind it is, if you look at a typical release pipeline, right, like you have source, you're pulling the source, building the project, right? Like you're running, build unit test. If that looks good, you're released to a staging environment. Maybe you do some testing and validation there, hopefully, right? And then you're released to production. That's how everybody starts. The problem with that, and a lesson again that we learned the hard way, is that there will always be mistakes, right? Like if you introduce a change into a system, there is always a probability, even if you have the best of intentions, you did lots of validation and testing and verification, manual, automated, and so forth, you have very high test coverage, right? There is always a chance and probability you will introduce an error, you will introduce a fault, there will be a side effect you didn't account for, and now this problem is in production. And that means for us, it will impact millions of customers worldwide, right? Like, which is a very bad thing. So how do we prevent that? How do we kind of what we call limit the blast radius, right? Like how do we ensure, even in the case if there is a problem that reaches production, it should impact the smallest possible number of customers. So how we do that is we are pessimistic about our deployment, right? Like as the name says, and we assume there will be a fault, so we try to contain it and catch it as quickly as possible before it reaches every customer. So instead of releasing to production, what we're doing is we're releasing it to a single machine, right? A single host, we call it one box, but it's a single machine and a single availability zone in a single region. And then we wait and observe this machine and we compare it to the rest of the fleet. What are the faults saying? What are the system metrics, CPU, memory, and so forth saying? What's latency saying, right? Like what are the business metrics on this machine saying? Logins per second or transactions completed, whatever your metrics is, right? And we compare it to the rest of the fleet, right? To the rest of the availability zone, to the rest of its pairs in the cluster in a sense, right? And only if the variation of that machine is within a certain defined threshold that you as a developer, of the owner of that pipeline can define, only then we feel comfortable enough after, like, let's say a few hours, right? Again, the timeline you can define as a developer to progress to the full availability zone, right? So a change will then progress to the full availability zone. And again, instead of progressing, we wait again, we compare this availability zone to another availability zone in the same region. What are the metrics saying? Faults, latencies, right? Availability, CPU, memory, disk load, and all of I/O requests, and all of those things. And only again, if after a few hours this looks good, it's within X sigma compared to the rest of the fleet, we feel comfortable enough to progress to the next AZ, until we have the full region, right? So only then, and this can take hours or days, depending on how you configured it. Now this change is in all, let's say, the Frankfurt region, right? And then instead of now going to all the other regions, we kind of repeat, right? And now we want to go to deploy to Dublin, same thing. We go to one machine, right? Go to one AZ and so forth, right? So eventually, typically the pipeline will speed up and we will deploy some of these regions in parallel. But the idea is always like we go very, very carefully, and we only go faster and faster the more confidence we have, right? The longer a change has been in production, the more confidence we have that it's probably okay, right? But if it turns out it wasn't, ideally we catch it, of course, in testing and so forth, or in staging. But worst case, we catch it on the one box, where it impacted only a few requests or only a very, very small percentage of customers, instead of it impacted globally everybody. And if so, we can automatically roll back, right? Like the pipeline will automatically block if this one box is not within X sigma compared to the rest of the fleet, and the deployment will be aborted and rolled back, and then a human can look at it and see what's the problem, why was this fault introduced, and so forth. So this means that even though for the developer, for the human in the process, the only thing they have to do is like git push, right, into the branch. The actual release process can take days or even weeks, depending on how you configured it, right? So we want to be very, very careful when we introduce a change before it's globally distributed. It reaches all of our regions and all of our availability zone and all of our machines and all our customers. So we want to be very, very certain there is no side effect that we didn't account for. This is something, again, obviously, like with our scale, with our global footprint, something that makes sense. It might not make sense for each of your use cases, but even if you only have a certain number of customer base, you're only installed in one region, this is something to consider, right? Like if you introduce a bug, do you want all of your customers to be impacted, or do you want to slowly dial up the number of impacted customers? Like CodeDeploy has a feature for this to do like blue-green deployments. It's how it's called in CodeDeploy, right? With Lambda, they also have a feature where you can kind of dial up traffic to new versions of the function. So the core idea is, again, you don't want to impact all your customers. And this is something we learned the hard way. Another lesson that we learned is, of course, do as much as possible of automated testing, right? So if you look at our release here, ideally, right, like we introduce as much testing as possible, right? So we have, if you look at staging, there's functional tests, there's load tests, performance tests, other tests, smoke tests, integration tests, and so forth. Typically, we also don't have like one single staging environment, right? Like there are multiple staging environments that run different kind of tests, right? Like you want to have the fast running test earlier, so you get feedback sooner. So you divide functional tests and so forth in that, right? So it's very common for these pipelines to be very long, or in code pipeline, right? Like you have to scroll a lot if you have a large pipeline, because we have dozens of these stages, multiple pre-prod stages or staging environments, so we would call them. You have the individual stages for the regions, for the one box, for the one AZs, and so forth, where the idea is, again, automate this fully so that it's not complicated for developers, but we have a high confidence in releasing a change, right? So developer productivity is high. Our belief in the quality and the availability and the service we're offering to you, we have a high confidence that works, right? Like that's kind of what we're aiming for. Highest possible productivity for the developer, highest possible confidence in security, availability, reliability in the services we're offering you. Another thing that is important, like how can you optimize the edit, compile, test loop, right, or EC2 loop, right? Probably not something revolutionary and very, I think, known to you, right? Like the idea of the sooner you've hit a problem, you run into it, the faster you will, or the easier and cheaper it will be for you to fix. So the inner loop, the edit, compile, test loop, right, like is when a developer like sits on their computer, they have their IDE, they're working a change, they're kind of making a change, hit run, get the output, maybe do debug, right, like do kind of troubleshooting with logs. That's when you catch a bug here, right, like that's the most efficient. The next step will be code review. That's, for example, something we enforce in our pipeline setting by default, where we say every change you introduce, has to have at least 1+1 from a colleague of you in your team, right? Because we saw that dramatically increase, again, the confidence in the changes, the reliability of it. So that's like a default quality gate you will have in your pipeline that you can override or disable, right? But you would, but by default, it's in there because we think it makes a lot of sense. Then you have the staging environment, as said, right? And then you have the production environment and so forth. And of course, the more on the left side you catch it, right? Like the more you shift left, you might have heard that said a few times, the better, right? So the ideal place to find a bug or a problem is in the inner loop. Code review is still great. Staging is good. Last resort is production. And as you saw, production is actually one box, one AZ, and so forth, one region, right? Like it's actually much more complicated than that. And we want to shift as much as possible to the left. That means higher developer productivity. And that's typically one of the most important resources, right? Like with the power of the cloud, I can scale my hardware. I cannot scale my developers as easily. So if I can take the burden from them, if I can move more things to the left, if I can accelerate their loop, right? I can make them more productive, and that is super, super critical. So with that, like we have a good idea of how do we actually develop and release software, right? So we covered, in a sense, the yellow part of that loop. We now have small autonomous teams that operate decoupled small products that have clear APIs, right? Like that have dependencies through defined interfaces. They're able to autonomously and independently build, test, release their software, and that software gets to customers. Now, what happens next, right? Like, how do we monitor? How do we execute on that feedback? One thing that we do is we're obsessed about operations. We're obsessed about operational excellence, availability, and so forth, right? All of you're building your business on our infrastructure, and you're counting on us that it works, that it's secure, that it's reliable, it's available, it's scalable, and so forth. So we better damn make sure that it is this, right? So what we do is we have lots of mechanisms that we have in order to ensure that ops-driven nature and that we provide the service at the quality level that you expect. So we have regular operational meetings where we look at dashboards and metrics that we look at, right? Resource monitoring, application monitoring, canary monitoring, client-side monitoring, and so forth, order drop rate, so business metrics, lots of things. A lot of them are probably obvious to you. The order drop rate is an interesting one where I see not enough teams think about that, right? Like, so it's obvious to meter maybe availability or fault rate and let's say CPU consumption or something. What is less obvious, but often in case of large-scale events, it's the first indicator to tell you something is wrong, is like a core business metric that is important to you. So at Amazon, for the retail website, there is a famous metric internally that we call the order drop rate, or the number of orders, right? Like if you look at the orders per second on Amazon.com, that's obviously for us a very important number. If that metric takes a dramatic dip, something is wrong, something is broken. We might not know yet what is it. Is it the payment? Is it like the buy button? Is it the your basket? Like what is actually broken? Like we might not immediately know, but we know something is up. Like we need to look at it immediately, right? Like there is a critical metric for you, a business metrics, logins per second, transactions per second, right? Like whatever your product is doing. That is absolutely critical. That's your core workflow, and if that is broken, something is wrong, right? Even though if number of faults or CPUs or database transactions, whatever it is, doesn't tell you yet, that thing will tell you it. So monitor that, alarm on it, right? And obviously there are dedicated metrics or dependent metrics that you're able to look at to understand what is wrong. Now, we're not only collecting all of these metrics, right? Look, we're regularly reviewing them, and we're trying to make sure that the teams obsess about them. And we're not relying here on what we call good intentions and kind of hoping the teams do that. We're trying to have mechanisms that ensure that that's actually happening. One very famous internal mechanism that we have is our operational meetings. So once a week, to give you the example, like once a week actually, all the AWS service teams are meeting, right? Every team has to send a representative. And then at that meeting, we have what we call the Wheel of Fortune, right? Like, or the wheel. It used to be an actual like wheel, like from the game of Wheel of Fortune, right? Like all the service teams are on it, and you spin it around, right? Nowadays, there are too many products to fit on a physical wheel, and obviously we're a very distributed company, so it's a virtual wheel. We actually had, I think, a year or two ago, like a blog post where we link to the open source implementation of that if you want to implement something similar. But the idea is, right, like you have to come in prepared. There are 200 plus teams coming in prepared with their operational dashboard. We spin the wheel, and then lucky winner, it's you, right? Now you have to present your operational dashboard to this whole room. You have to walk everybody through your graphs and charts and say, here you can see our availability of all our regions for this component, right? Like, and you need to be able to explain every dip, every spike, what happened here, why is the latency for the Frankfurt region X milliseconds lower on average than for the US East region, right? What's the difference? What's going on here? What was this dip? What was going on there, right? Like where you have to be able to explain that. You have to be on top of that. You have to be able to explain what's the customer experience. Why did this happen? What's the root cause? How are we making sure it doesn't happen again, right? And everybody in the room is like trying to see, like are you really on top of things? Do you understand this well? Do we need to dive deeper here, right? Like, is there a lesson in here that everybody else in the room can learn? But the mechanism is you have 200 plus teams come in prepared. I could be up, right? Like, I don't know. But you only look at 2 or 3 a week, but everybody has to come in prepared. So that's a great mechanism that we established, right? Like where over the years it helped us scale as we grew, right? It worked fine with a handful of services. It works with more than 200, where it allows us to ensure that teams obsess over that, right? Like, and you have all the senior leaders in the room, which also sends the message like, this is important to us. Everybody's here, right? Like this seems to be super critical to Amazon, and that helps kind of to create that message and the culture with every engineer. Well, like availability, security, those things are super critical, right? Like the senior leaders take the time. Everybody's here, and you have to prepare, right? Like you don't want to embarrass yourself, and you will be grilled in that room, right? Like and if you're not on top of things, if you cannot explain what's going on with your product, if you cannot explain why all of you don't have the experience you should have, right? So like you want to have flat lines, availability, right? Like fault rate and so forth. And if your graphs look like this, you have a lot of explaining to do, right? So that's one example for how we obsess about these operations, how we hold teams accountable to the product that they built, right? To come back to the accountability idea of the 2 pizza teams. If you pick a particular technology, if you pick a way to release, right? We will hold you accountable to how well it works in production. It will reflect very poorly on you as a leader of that team, on that team, right? If your product doesn't hold up to the promise we're making all of you, which is our services are secure, reliable, available, scalable, and so forth. That's what you expect from us, and that's one way how we ensure that they are. The other thing, very related, is how do we, if we monitor everything, how do we measure also from the business side, right? I said at the beginning that the teams are also owners of their, in terms of the roadmap of the features, right? So the teams define what is the right feature to build, who is our customer, what's the use case we want to targeting, right? Like what's the next feature we should do first, what's the roadmap for next year, for the next few years, and so forth. And we measure all of these things too, right? So it's not only on the operational side, it's also on the actual product sides. What's the feature adoption? What's the segment growth? What's the funnel and all of these things? What's the cost? What's the P&L for this product? Where essentially every AWS product, like I said earlier, you can think of it of a mini startup, a mini company. What's their P&L? What's their growth rate? What's their ARR? What's the customer adoption, right? And those are, again, data that we obsess about. Typically not the engineers, typically the leaders, the product managers, but it's the same idea. You need to be able to be on top of that. So right after the operational meeting, there is a business meeting where we do exactly kind of the same idea, not quite with the wheel, but the same idea of looking into these metrics. There are weekly business reviews, monthly business reviews, where we look at these metrics decks, where team come and say, here is my metrics deck, here's how my product behaves, here's why, and here's what we think about this, and here's how this feature performed. And we also do the dive deep and the grilling to make sure that we're doing the right thing to serve you, right? Like we're building the right features, we're building the right products, it has the traction that we expect it to be. And again, we obsess about these numbers in order to make sure that we're doing the right thing. So it's, again, the very, very similar idea of we give you a lot of autonomy, we give you a lot of freedom, but then we hold you accountable, right? Like if you said you want to get to this number of users or to this adoption or to this revenue targets, right? Like you better show us the numbers that will get you there. Why do we think that is? Why do we think the adoption of this feature will get us there, and so forth? The general idea is, right, like when we build a new product or build a new team, we set a goal, we said, here's the use case that we're trying to address, here's the customer persona. Now we get a small team together and say, you figure it out how to solve this problem, both from a business side, from a product side, from a technology side. But then we want to double check, we want to kind of ensure that you're getting there and that you're doing the right things. And that's kind of the core idea of how Amazon operates, right? Like small autonomous teams that have a lot of empowerment to make their own decisions, but at the end of the day, we'll hold them accountable to the results. Now, if you do all of these things, you have like some of the core ideas figured out of how Amazon operates. There is kind of one last but not least concept that I want to walk you through, which is kind of the fundamental idea behind all of this. Like all of that only works if you do this, right? If you listen to your customer. It sounds obvious, but it's actually in practice very, very hard. Like this is kind of where most of the things fail. Like if you have something that doesn't work, right? Like in theory, how do you know what to build, right? What do we do, right? Like, and probably if you talk to some of the Amazonians here today, you experience a lot of that. Like, we go to our customers, we ask them what they want, right? Like, we take that feedback on what we should improve and change in our products, and then we course correct. We add this feature, we iterate, right? Like, we work with that. It sounds simple, but it's very hard in practice because there is one big pitfall that you can fall into, right? Which is the feature versus need. This is an actual product you used to be able to buy on Amazon. No longer, they took it down. But this is something you could buy, which sounds cool on paper, right? Like a thing that can do all of these things, but in practice, nobody will buy this thing, right? Like where it's mistaken for, I have a cool feature here, I have something that sounds useful, like some cool new technology, where can I apply it, right? Instead of starting with, what's actually the need that the customer has? What are we solving for the customer? Why should they care? Right? Why should all of you care? And that is the fundamental thing that we always start with is what's the customer problem? What's the itch that you need scratching and how can we help you achieve that? You need to get that right. And that's the hardest thing to do from everything that I talked about, right? The mechanism that we have, coming back to the idea if you need mechanisms for doing that at Amazon, is what we call the working backwards process. If you Google working backwards or Amazon PR and FAQ process, you will find a lot of documentation about this. Here's a blog post by Werner Vogelsee, our CTO, where he talks about it. The core idea is like to work backwards from the customer requirements, right? So instead of starting with, here's some cool piece of technology, where can I apply it, all right, is to say, my customer has a particular problem. There is like some need that they have that they want fulfilled, and there are some obstacles in the way. There is some friction with this process. And then how can we then get rid of that friction? How can we remove the friction? And what is the right experience that you should have, right? And only then, when we all agree, this is the right problem to solve, it's the right use case, it's the right customer, this solution, how you describe it, like in terms of the experience, the final experience, sounds like that is what customers would want, right? Only then we think about how do we actually implement this, right? How does that need to be built, right? Like that's more like, who cares about that? Like kind of, right? Like the team, figure it out, right? Like, but we spend a lot of time and a lot of iteration on making sure we nailed that customer problem. We know what is it that you want, right? Like what is it that you would appreciate? What is it that you would, at the end of the day, pay for, right? In order to have solved. And only when we're sure that this makes sense to do, then we say, okay, now let's get a team together. Let's tell them, here's the problem we want you to solve, and then figure out the details, right? Like the details is what you're here for, is to in that sense, the idea is, right, like align on the problem, hire clever people, and get out of their way. And then regularly ensure that they're doing the things, right? Like hold them accountable to the progress to that result that you agreed on. The way how we do this is very peculiar to us. I've seen other companies do things like they call it like document-driven design, right? Or README first driven design, where if you write a program, you write the README first, you write the documentation first, and you say, this is what I want to result to. What we do is we write a press release. So we write up the document as, here is like a press release how we would announce this product, right? It's not the real press release that will go out a year or two later. It's here's how we would announce and talk about it. And that description has to excite the customer, right? Like it talks, today Amazon is probably announcing product X that solves XYZ for customers. Before, the customers always had this problem that they couldn't do ABC. Now this product, by introducing feature 1, 2, and 3, like solves this problem for customers. That's the idea of the press release, right? Like you could use different formats. It doesn't matter too much. That's the one we use. But the idea is you need to lead with the customer. You need to lead with the customer problem. You need to lead with how you're going to make their life better. And only then you say, oh, by the way, we're doing this by A, B, C, D technology or whatever, right? And then there is an FAQ part to it that describes a lot of the follow-up questions you might have is like, how does it work? Where is it installed? How do I use it? How do I upgrade? What does it cost? Does it work with this? Does it work with that? Right? Like this is kind of the product specification, right? Like that's our requirements document, essentially, is that FAQ and that PR. And that's what we give the team to say, here's what we want you to build. Here's what we want you to implement. It's typically then accompanied also by some user experience, mock-ups, designs, right? Like depending on what it is that we're building, like there might be some more details there, like a user manual or so forth, right? But the idea is, again, you describe the experience. That's what matters to all of you. You don't care what programming language is S3 implemented in, right? Like that doesn't matter to you. The S3 team has to care about that, right? Like how do they provide the most durable, fastest, cheapest storage for you? How you provide it, who cares? Let the team figure it out. And that's what we literally hand over to the team and let them work on, right? Like that's the core idea of lead with the customer. And for cases where we as a company, right, like didn't achieve that, most often is because we didn't stick true to this process. And that's kind of the mechanism we use internally extensively to ensure that we're doing the right thing, we're building the right product, and that's kind of sets the agenda and the requirements essentially for those two pizza teams that I talked about at the beginning. That's what we're giving them as the input, right? Again, it's a living document that they work over time, right? So maybe, for example, in the beginning, the FAQ says that this thing supports Linux and Windows, right? A few months into the project, right, like you figure it out with engineering and the project, actually, if we support also Windows, it will take us like 6 months longer to launch. Maybe we take Windows out of the scope for the first release, right? And then you change the FAQ and says, actually, in V1, we won't have Windows, it will only have it in V2, right? Like, so it's a living document that captures like the specification of the experience we want to deliver customers. And then the engineers figure out how do we actually make that happen. And obviously, there's a lot of back and forth between engineering, product management, leadership, right? Like UX design and so forth. But the idea is, like, we always lead with the customer experience. And if we do that, we hopefully have lots of happy customers, right? And this is kind of the idea of how we typically operate our teams. So yeah, with that, hopefully this was useful to you, right? Hopefully you learned a little bit about how we as Amazon develop software, how we release software, how we staff our teams, how we set the agenda, how we let them operate. The core idea, like I said, is work backwards from the customer, have small autonomous teams, decouple them as much as possible, give them the autonomy to pick their tech, right? And then have clear interfaces between them to operate. Obviously, that is not free. That's not perfect, right? Like, there is a drawback to that. I'm sure many of you in the room used the AWS console before, right? And then notice, why does the EC2 console look slightly different than the S3 console, look slightly different than the Lambda console? Why maybe do these things here are called differently than these things over there, even though they're pretty much the same concept, right? And the answer is because of these small autonomous teams, right? Team A decided to like prioritize adopting the new design. Team B decided not to do it yet. Team C maybe looked at it but doesn't believe in it, right? And they pick their own priorities. So we don't force that integration. Like, it happens organically over time, right? Like sometimes it doesn't happen at all. But we believe that the trade-off is worth it because it allows us to operate faster, iterate faster with your feedback, release faster, get your feedback and iterate, rather than force the integration. But there are trade-offs, of course, right? Like, if you have these small autonomous teams, the one big one would be an integrated experience, right? It's harder to achieve. It costs more effort because it is a little bit like cat herding in that sense. Yeah, so with that, thank you very much, everybody. Hopefully you enjoyed the talk. Hopefully you enjoyed the day. And I will be here for a few more questions in case you have any. So yeah, thank you, everybody.